In the realm of cloud computing, container deployment has emerged as a pivotal strategy for managing applications. Containers encapsulate an application and its dependencies, ensuring consistency across various environments. This presentation delves into the intricacies of planning and executing a container deployment, particularly within the context of managing an Azure AI solution. We'll explore the benefits, challenges, and best practices, providing a comprehensive guide to mastering this essential skill. Containers are lightweight, standalone, and executable software packages that include everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. Unlike virtual machines, containers share the host system's kernel, making them more efficient and faster to start. This efficiency makes containers ideal for deploying AI solutions, where rapid scaling and resource optimization are crucial. Containerization offers numerous advantages, particularly for AI solutions. It ensures consistency across development, testing, and production environments, reducing the "it works on my machine" problem. Containers also enhance scalability, allowing for rapid deployment and scaling of AI models. Additionally, they improve resource utilization and isolation, ensuring that applications run smoothly without interfering with each other. Despite its benefits, container deployment comes with its own set of challenges. Managing container orchestration, ensuring security, and handling persistent storage are some of the key issues. Orchestrating containers at scale requires robust tools and strategies, while security concerns necessitate stringent measures to protect data and applications. Persistent storage can be tricky, as containers are inherently stateless, requiring external solutions for data persistence. Effective planning is crucial for a successful container deployment. Start by defining your objectives and requirements, considering factors such as scalability, performance, and security. Choose the right containerization platform and orchestration tools, such as Docker and Kubernetes. Plan for resource allocation, network configuration, and storage solutions. Additionally, establish a robust monitoring and logging strategy to ensure smooth operation and quick troubleshooting. Selecting the appropriate tools is a critical step in container deployment. Docker is a popular choice for containerization, offering a comprehensive platform for building, shipping, and running containers. For orchestration, Kubernetes is widely used due to its powerful features for managing containerized applications at scale. Azure Kubernetes Service, AKS, provides a managed Kubernetes environment, simplifying deployment and management on Azure. Setting up your environment involves several key steps. Begin by installing Docker and Kubernetes on your local machine or cloud environment. Configure your network settings to ensure seamless communication between containers. Set up persistent storage solutions, such as Azure Blob Storage or Azure Files, to handle data persistence. Finally, configure security settings, including access controls and encryption, to protect your applications and data. Building and packaging your application into a container involves creating a Docker file, which defines the environment and instructions for building the container image. Ensure that your Docker file includes all necessary dependencies and configurations. Use Docker commands to build the image and test it locally. Once the image is ready, push it to a container registry, such as Azure Container Registry, for easy access and deployment. Deploying your containerized application to Azure Kubernetes Service, AKS, involves several steps. First, create an AKS cluster using the Azure Portal or CLI. Configure your cluster settings, including node size and scaling options. Deploy your container image from the Azure Container Registry to the AKS cluster using Kubernetes deployment manifests. Monitor the deployment process and ensure that your application is running smoothly. Monitoring and logging are essential for maintaining the health and performance of your containerized applications. Use Azure Monitor and Azure Log Analytics to collect and analyze metrics and logs from your AKS cluster. Set up alerts to notify you of any issues such as resource shortages or application errors. Regularly review logs and metrics to identify and address potential problems before they impact your application. Scaling your containerized application involves adjusting the number of running containers based on demand. Use Kubernetes' built-in scaling features, such as horizontal pod autoscaler, to automatically scale your application. Configure scaling policies based on metrics like CPU and memory usage. Ensure that your infrastructure can handle the increased load and monitor the performance to maintain optimal operation. Security is a critical aspect of container deployment. Implement best practices such as using minimal base images, regularly updating images, and scanning for vulnerabilities. Use Kubernetes security features like role-based access control, RBAC, to manage permissions. Encrypt sensitive data both at rest and in transit. Regularly audit your security settings and practices to ensure compliance with industry standards and protect your applications from threats. Persistent storage is essential for stateful applications. In a containerized environment, use external storage solutions to manage data persistence. Azure offers several options, such as Azure Disk Storage, Azure Blob Storage, and Azure Files. Configure your containers to use these storage solutions, ensuring data is retained even if containers are restarted or rescheduled. Plan for backup and disaster recovery to protect your data. Adhering to best practices can significantly enhance the success of your container deployment. Use version control for your Docker files and Kubernetes manifests. Implement continuous integration and continuous deployment CI/CD pipelines to automate the build and deployment process. Regularly update and patch your container images. Monitor resource usage and optimize your containers for performance and efficiency. Finally, document your deployment process and configurations for future reference. To illustrate the concepts discussed, let's examine a case study of a successful container deployment. A company needed to deploy a scalable AI solution on Azure. They started by planning their deployment, choosing Docker for containerization and AKS for orchestration. They built and tested their application, deployed it to AKS, and set up monitoring and logging. By following best practices and addressing challenges, they achieved a robust and scalable deployment, significantly improving their application's performance and reliability. In conclusion, planning and executing a container deployment involves careful consideration of various factors, from choosing the right tools to ensuring security and scalability. By following the guidelines and best practices outlined in this presentation, you can successfully deploy and manage containerized applications on Azure. As a next step, consider exploring advanced topics such as service mesh, multi-cluster management, and hybrid deployments to further enhance your container deployment skills.